All right, this one will be much shorter, I promise. Okay, warm-ups. I think we can always do warm-ups at school, so I don't have to bore you with these. Whoops, sorry. We'll do those in class. All right, let's talk about intercept form. Okay, so far we've done two different forms, right? We've done the root one, the vertex one, and then the standard one. I think this is the last one. It's called intercept form for a reason. We can read intercepts right out of the thing. So when you look at this equation, the A is the same A it's always been, which is wonderful. But here the P and the Q are going to be the coordinates on the axis where it crosses, well, the graph crosses the axis on the x-axis. Yeah, it says that right below that. Okay, great. Sketch the graph of this. Well, okay, +5, -1 in intercepts. You may remember this from when you used to solve these when you were first learning how to solve quadratics after factoring. If this were this happened to be where y equals 0, then we know that x either has to be -5 or +1, which is exactly, whoops, I said -5, -5 or +1, which is exactly what we just said about, excuse me, how this equation is going to work. This doesn't tell me right away where the vertex is. Doesn't tell me if it opens up or down. I did say it was the same value of A, so A here is 1. So this is going to be congruent to the parent parabola, where we have like, vertex and then 1 over 1 up 1 over 2 up 4, that kind of thing. So sometimes you can just look at this right away and go, oh, okay, so since those are six apart, I know exactly how far down it's going to go. That's kind of tricky. That's kind of a slow way to do it in general, but sometimes it's pretty quick and it just kind of pops out at you. Anyway, in general, the way to do this is, well, we know if those are the vertices and we know this thing is symmetrical, we know that the axis has to be exactly halfway between those two. So there's a formula for that, but I'm just looking at this picture right here going, okay, it has to be along the line where x equals -2. So I know the vertex has an x coordinate of -2, and if I try to find the y coordinate, all I have to do is plug that in for these things. So the y coordinate at the vertex is going to equal -2 + 5 times -2 minus 1, which is simply 3 times -3, which is -9. So down here at -9 of a vertex. And then if you had to, you could do this. You go, yep, over 1 up 1, over 2 up 4. So that's going to be here. Yep, and over 3 up 9, and that's exactly what we were seeing. You could have maybe figured that out, again, knowing that this is 3 and 3. I could have known maybe since this is A of 1, it's congruent to the parent parabola with a sort of a spread of 3 each way there. I know that had to be 3 squared, which is 9 above the vertex. I mean, I could have done that without solving algebraically, but you know what? This makes me feel better, so we're going to do that. Okay. Quarter done. All right. Consider the quadratic function of this form. State the intercepts. Well, the intercepts are going to be -3 and 5. Those are the places where it's going to cross 2, 4, 5. The x-axis. Find the equation of the axis of symmetry. Okay, now the A is a little bit different here, so this isn't quite as predictable. But I do know in terms of symmetry, if I just cut this in half, I know the line of symmetry has to go right through there. This has a spread of 8, so it looks like it's going to be 4, so it's going to be right there, axis of symmetry. So that's x equals 1. Vertex then is going to have an x coordinate of 1. The y coordinate is when x equals 1. Don't forget the third. 1/3 times, what was this, 4 times -4, that's interesting, which is positive 16/3. Ugh, that's not very fun. Might be helpful to think, because I have to actually graph this, might be helpful to think of that as 5 1/3. And that's positive, yeah, okay. Oh yeah, this opens down because it's -1/3. So 5 1/3, 1, 2, 3, 4, 5 1/3's about there. I know it's 1/3, that's kind of nice. This is 1/3 above the, this line here. So if I go over 1, I should go down exactly 1/3, so that's kind of nice. I could have figured that out also by putting numbers in, like putting y equals 0 in for this is pretty quick. I can figure that out. And of course, there's all this symmetry. I have 5 points now. 5 points is generally enough to know kind of where the parabola is going to go, so that's okay. Sorry, it gets so thin when I zoom out sometimes, or zoom in sometimes. Oh, determine the y-intercept. Oh, I already saw that there. It was at 0, 5, which reminds me, we never really talked about this. I said, when it said state the x-intercepts, you could say it that way, or you could say that we're talking about -3, 0. This is probably better. And 5, 0. Which way are we going to go with points on that? I don't know. I need to talk to Miss P and see how she feels about this when you get to calculus. But conceptually, those kind of mean the same thing. Graph the parabola showing 5 points. Done. Rewrite the equation. General form. Okay. So general form was the form that looked like this. The best way to do that and this is what next lesson's about, 2.4. The best way to go about that is to go from this, which is root form or intercept form, to standard form, is simply to expand it. Negative 1/3, and then I just kind of FOIL this out. This is x squared minus 2x minus 15, and then distribute the negative 1/3. Negative 1/3 x squared. I've been grading your area and volume things too much. 2/3 x plus 5. I believe that's it. Okay. Startled cat jumps into the... Oh, yeah, this is a funny problem. I remember this from last year. Okay. How high is the cat for 0.5 seconds? Well, all we do there is we put in 0.5 for t. Negative 2 times 0.5. 0.5 minus 3. That's just going to be negative 1 times negative 2.5, which is positive 2.5. And this is in what? Oh, inches. Half a second after the jump. Okay, that seems reasonable. How long is the cat in the air? Okay, maybe we should start thinking about this, because I think in the end they're going to ask us to graph it. Or even if they don't, it's not a bad idea. At 0, sorry, just trying to get a picture of what's going on here. This thing is going to have, because we already know we're kind of in the intercept form section of the unit here. This is going to have intercepts at 0 and at positive 3. So we're going to hit the ground at 0. We're going to hit the ground at 3. I already know. So the cat jump is going to go kind of like that. I know at half a second it's going to be at 2.5. I actually don't know right away if that half second thing is going to be there or there. So I'm going to fill that out first. But that helped with this, right? And how high does the cat jump? I need to know this, so I need to know the coordinates of the vertex. Well, knowing that the cat hits the ground at 0 and 3, it's a really long hang time, actually. Think about 3 seconds in the air. That's a pretty high jump, or a pretty slow fall, or maybe we're on the moon or something. Anyway, this has to be exactly 1.5 seconds. So I can figure this out if I just plug this in and try to find h, or try to find y. Y equals negative 2 times 1.5 times 1.5 minus 3, which is negative 3 times negative 1.5, which is just 4.5. And that's inches. Is that it? Oh, yeah, they weren't going to ask. Yeah, 4.5 inches for 3 seconds? That doesn't seem like physically possible, but okay. Page 2. When we knew, yeah, we kind of knew where the intercepts were. Oh, no, I'm not drawing. We knew where the intercepts were, and then we said, oh, halfway between there must be what the axis of symmetry is. Next, we have a quadratic equation with zeros at blank and blank and a y-intercept at blank. Okay, so we're going to put this in this form, and this is going to be something that's, P. This is going to be something that a skill you're going to have to figure out by the end of this unit is, okay, they give you this information, what's going to be the best version of a quadratic to head towards. Here, since they gave us zeros are also known as roots, zeros are also known as intercepts, so intercept form and root form is going to be the one that's going to be most, accessible, I guess. So there's the negative 2 in this equation, and there's the positive 3. Now I just basically have to figure out A. I have everything else in this equation. And the only other information I have is y-intercept at 12. So if you think about that, what that means in terms of coordinates, if the y-intercept is 12, that's what y is negative 12, when x is 0. So this is negative 12 if x were 0. And from this I can figure out A. A is 2, so I can just rewrite this now. Y equals 2 times x plus 2, x minus 3. Some people have a hard time realizing, okay, when I get done with this, what do I leave as variables? What do I plug in as numbers? We've got to have x's and y's in the end. The equation for the parabola has got x's and y's in it and nothing else. Just, no other variables. It's just the values of the things that make it what it is, but the x's and the y's have to stay x's and y's. Okay. I think you're actually pretty good at that, but some people do get confused. Analyze this function with all these different features. Okay. The x-intercepts would be the ones that are staring at me. Oh, this is interesting. There's two of the same. 2. And of course, remember that's 2, 0. The fact that there's 2 of the same there is going to have some implications. We'll see what happens as we get there. Find the equation of the axis of symmetry. Well, those are the 2 roots. I know that's the only place it crosses the axis, so this is going to be some kind of parabola that does this. That's kind of the main implications I was just talking about. So the axis of symmetry is going to be when x equals 2. Determine the coordinates of the vertex. Already did that. This is going to be 2, 0. And again, how do I know that? Well, it's got 2 roots. It's got one double root, and that's at 2. Determine the y-intercept. Okay, that's a little bit trickier. I have to try to figure this out when this equals 0. X minus 2, x minus 2. Wait a second. Y-intercept, that's not what I wanted to do. That's when x equals 0. Okay, so I'm trying to figure out y if x is 0. There we go. This is 2 times negative 2 times negative 2, which is 8. All right, so I'm going to have an 8 here. And I guess that's enough to graph the parabola. I have those. I know that a is 2, so when I go over 1, I should go up 2. That's 5 meatballs. That's enough information. Sorry, it looks kind of pointy, but that's what we have. Okay, and we write in vertex form. Again, we're just going to... Oh, in vertex form. Oh, well, the good news is we know the vertex. The vertex is at 2, 0. And we know that a is 2. So, yeah, all we have to do here is put in what we know. Y equals 2 times, and then the vertex is x minus 2 squared, sort of plus 0, which I don't need. But that's the rest of the vertex form. So that's enough. You can just say y equals 2 times x minus 2 squared. Okay, we are cooking. Do I need to do this? Maybe I need to save some for class. I think I'm going to save this one for class because this has nice all 3 versions in one place. We kind of did that. How come it does that? All right. We kind of did this on one of these earlier ones. Okay, then, yeah, this is getting ready now for putting all 3 of them together. Yeah, this might be better to do in class. Let me pause and think for a second. Change my mind. I think this is going to be better on video because then you can refer to this later. So how do I find the axis of symmetry in all these different versions? How do I find the vertex, and how do I find the x-intercepts? Well, some things are named after what they are, kind of, and things are kind of nice. Like the vertex right here is really simple. It's h, k. Intercept is named for intercept form. This is also known as root form. This is pretty easy. That's what they're named after, so that's probably kind of nice. The other thing that's kind of nice about all 3 of these forms when you're comparing all 3 of them is that the a would be the same. If you're going to convert from one to the next, it would be the same value of a in all of those, and a means the same thing in terms of graphically. It's about how tall the parabola is. All right, so axis of symmetry. Well, I already know that the vertex is at h, k, so this is simply x equals h. In all of these, it's going to be x equals whatever that x coordinate is, here. X is going to equal that thing. Sometimes that's easy to find like this one, and sometimes it's not. In fact, let's go to, I'm going to go in between these different forms. They told us here that this one was x equals negative b over 2a, and then I'm just going to plug that directly in here, negative b over 2a. So that's great. Axis of symmetry in intercept form, we kind of did that. I should go back here. So now we go back here. Halfway between the 2 is where we want to figure out where the axis of symmetry is. So I believe we just go p plus q divided by 2. That's the, sorry, p plus q divided by 2. That's the x-coordinate of the vertex. Oh, and then for all these, to try to figure out how to get from x to y here and here, you simply have to plug it into the equation, which was easier in vertex form days, but it's not as easy here. F of that. And here it's f of that. So basically, this is a really long way to say plug it in and find y, which we've just been doing, especially for intercept form. How do I find the x-intercepts? This is when y equals 0. Solve for when, I should say solve for x when y equals 0 by factoring, like this again was the main thing you did in 8th grade, or quadratic formula. Okay, and then Same thing on vertex form. Solve for x when y equals 0. But here that's easier because you already have this form of the equation. Don't expand the x minus h. It's always going to be, I'm just going to say like, it's going to be something like negative k equals a times x minus h squared. Then you divide by a. Negative k over a equals x minus h squared. Then square root dot dot dot. Actually, I should say plus or minus square root. This is really hard to read. Then plus or minus square root. I'm not going to do the whole thing, but yeah, that you can solve this without expanding, which is kind of the point. Okay, write the equation for the following parabola in 3 ways. Oh, I think this is going to be a great one to do in class. I don't want to do this now. I want to make this video short. Okay, great. I'll see you in class.